Hi everyone, welcome to this module ARP. The first point is ARP Overview. If your network is using the IPv4 communication protocol, the address resolution protocol or ARP is what you need to map IPv4 addresses to MAC addresses. This topic explains how ARP works. Every IP device on an Ethernet network has a unique Ethernet MAC address, media access control. When a device sends a Ethernet layer 2 frame, it contains these two addresses: destination MAC address, the Ethernet MAC address of the destination device on the same local network segment. If the destination host is on another network, then the destination address is the frame will be that of the default gateway, for example the router. The next is the source MAC address, the MAC address of the Ethernet NIC on the source host. NIC is Network Interface Card. The figure illustrates the problem when sending a frame to another host on the same segment on IP4 network. And I need to send information to this address 192.178.1.7, but I only have the IP address. I don't know the MAC address of the device that has that IP. Okay, this is the destination of the packet, and this H1 or host 1 only has the IP address. To send a packet to another host on the same local IPv4 network, a host must know the IPv4 address and the MAC address of the destination device. The device destination IPv4 address are either known or resolved by device name. However, MAC address must be discovered. A discover uses Address Resolution Protocol (ARP) to determine the destination MAC address of a local device when it knows its IPv4 address. ARP provides two basic functions: resolving IPv4 addresses to MAC addresses and maintain a table of IPv4 to MAC addresses mappings. ARP functions: when a packet is sent to the data link layer to be encapsulated into Ethernet frame, the device refers to a table in its memory to find the MAC address that it is mapped to the IPv4 address. This table is stored temporarily in RAM memory and called the ARP table or the ARP cache. The sending device will search its ARP table for the destination IPv4 address and a corresponding MAC address. If the packet's destination IPv4 address is on the same network as the source IPv4 address, the device will search the ARP table for the destination IPv4 address. If the destination IPv4 address is on a different network than the source IPv4 address, the device will search the ARP table for the IPv4 address on the default gateway. In both cases, the search is for an IPv4 addresses and a corresponding MAC address for the device. Each entry or now or row of the ARP table links an IPv4 address with a MAC address. We call the relationship between the two values a map. This simply means that you can locate an IPv4 address in the table and discover the corresponding MAC address. The ARP table temporarily saves cache the mapping of the device on the LAN. If the device locates the IPv4 address, its corresponding MAC address is used as a destination MAC address in the frame. If there is not entries found, then the device sends an ARP request. And press play in the figure to see an animation of the ARP function. Okay. I must send out an ARP request to learn the MAC address of the host. And the other host respond, and only the host destination reply a message. Okay. ARP operation and ARP request. An ARP request is sent when a device needs to determine the MAC address that is associated with an IPv4 address. and it does not have an entry for the IPv4 address in the ARP table. ARP messages are encapsulated directly within an Ethernet frame. There is no IPv4 header. The ARP request is encapsulated in an Ethernet frame using the following header information. Destination MAC address. This is a broadcast address. Require all Ethernet NICs on the LAN to accept and process the ARP request. Source MAC address. This is MAC address of the sender of the ARP request. And type. ARP message have a type field of this this message. This informs the receiving NIC network interface card that the data portion of the frame needs to be passed of the ARP process. Because ARP requests are broadcast, they are flooded out all ports by the switch, except the receiving port. All Ethernet NICs on the LAN process broadcast and must deliver the ARP request to each operating system for processing. Every device must process the ARP request to see if the target IP4 address matches its own. A router will not forward broadcast out of their interface. Only one device on the LAN will have an IP4 address that matches the target IP4 address in the ARP request. All other devices will not reply. And the next step in this process, ARP operation and ARP reply. Only the device with the target IP4 address associated with the ARP request will respond with the ARP reply. The ARP reply is encapsulated in an Ethernet frame using the following header information. Destination MAC address. This is the MAC address of the sender of the ARP request. Source MAC address. This is the MAC address of the sender on the ARP reply. And type ARP message have a type of field. This informs the receiving NIC network interface card that the data portion of the frame needs to be passed to the ARP process. Only the device that originally sent the ARP request will receive the unicast ARP reply. After the ARP reply is received, the device will add the IPv4 address and the corresponding MAC address to its ARP table. Packets destined for the table IPv4 address can now be encapsulated its frame using its corresponding MAC address. If no device responds the ARP request, the packet is dropped because a frame cannot be created. Entries in the ARP table is time-stamped. If a device does not receive a frame from a particular device before the timestamp expires, the entry for this device is removed from the ARP table. Additional static MAC entries can be entered in ARP table, but this is really dumb. Static ARP table entries do not expire over time and must be manually removed. Note IPv6 uses a similar process to ARP for IPv4. Note ICMP version 6 neighbor discover ND. IPv6 uses neighbor solicitation and neighbor advertisement message similar to IPv4 ARP requests and ARP replies. Okay. And ARP role in remote communication. When the destination IPv4 address is not on the same network as the source IPv4 address, the source device needs to send the frame to its default gateway. This is the interface on the local router. Whenever a source device has a packet with an IPv4 address on another network, it will encapsulate the packet in a frame using the destination MAC address of the router. The IPv4 address of the default gateway is stored in the IPv4 configuration on the host of the host. When a host creates a packet for a destination, it compares the destination IPv4 address and its own IPv4 address to determine if the two IPv4 addresses are located on the same layer 3 network. If the destination host is not on its same network, the source checks its ARP table for an entry with the IPv4 address of the default gateway. If there is not an entry, it uses the ARP process to determine a MAC address of the default gateway. And removing entries from an ARP table. For each device, an ARP cache time removes ARP entries that have not been used for a specific period of time. The time differs depending on the operating system of the device. For example, the Windows operating system stores ARP tables entries between 50 and 45 seconds, and illustrated in the figure. Okay, I will remove this ARP entry if I have not used in within 15 to 45 seconds. Okay. Note: MAC addresses are shortened for demonstration purposes. Okay, and commands may also be used to manually remove some of all of the entries in the ARP table. After an entry has been removed, the process for sending an ARP request and receiving an ARP reply must occur again to enter the map in the ARP table. In ARP tables on devices on Cisco router, the show IP ARP command is used to display the ARP table as shown in the figure. Protocol, address, age, hardware address, type, and interface. On a Windows 10 PC, the ARP command is used to display the ARP table as shown in the figure. Okay, ARP issues, ARP broadcast, and ARP spoofing. As a broadcast frame, an ARP request is received and processed by every device on the local network. On a typical business network, this broadcast will probably have minimal impact on the network performance. However, if a large number of devices were to be powered up and all start accessing network service at the same time, there could be some reduction in performance for a short period of time. As shown in the figure, after the device sent out the initial ARP broadcast and have learned the necessary MAC address, any impact on the network will be minimized. All devices power on the same network, share media, multiple access. ARP broadcast can flood the local media. In some cases, the use of ARP can lead to the potential security risk. A threat actor can use ARP spoofing to perform an ARP position attack. This is a technique used by a threat actor to reply to an ARP request for an ARP IPv4 address that belongs to another device, such as the default gateway as shown in the figure. The threat actor sends an ARP reply with its own MAC address. The receiver of the ARP reply will add the wrong MAC address to its ARP table and send these packets to the threat actor. Enterprise-level switches include mitigation techniques known as dynamic ARP inspection. The DAI is beyond the scope of this course. Okay, this is the threat actor. I will send an ARP reply and pretend to be the default gateway. ARP request, I need the MAC address of the default gateway. Note: MAC addresses are shortened for demonstration purpose. Okay. And we have those two activities for the next. Finish with check your understanding ARP. What two functions are provided by ARP? ARP, choice 2. Maintain a table of ARP addresses to domain names. Maintain a table of IPv4 to MAC addresses mapping, and resolve IPv4 addresses to domain names. Resolve IPv4 addresses to MAC addresses. That's right. ARP has two primary functions: maintain a table of IPv4 to MAC addresses mapping, and determine the MAC addresses of those IPv4 addresses. Where is the ARP table stored on a device? in RAM. That's right, ARP table is cached temporarily in RAM. Which statement is true about ARP? An ARP cache cannot be manually deleted. No. ARP entries are cached permanently. Yes. No. Yes. The ARP table is cached temporarily in RAM. Which command could be used on a Cisco router to view its ARP table? This is show IP ARP. Show ARP table. I don't know. Okay. Reset. Is this? The command show IP ARP is used on Cisco routers to view the ARP table. And what is an attack using ARP? ARP broadcast. Okay, two security issues with ARP request are the ARP message are sent as a broadcast and can be spoofed. Go back. Reset. What is an attack using ARP? Hopkins attacks. Okay. Two security issues with ARP request are that the ARP messages are sent as broadcasts and can be spoofed. Okay. And finish with address resolution summary. What did I learn in this module ARP? To send a packet to another host on the same local IPv4 network, a host must know the IPv4 address and the MAC address of the destination device. Device destination IPv4 address are either known or resolved by device name. However, MAC address must be discovered. A device uses ARP to determine the destination MAC address of a local device when it knows its IPv4 address. ARP provides two functions, basic functions resolving IPv4 address to MAC addresses and maintain a table of IPv4 to MAC addresses mapping. The sending device will search its ARP table for a destination IPv4 address and a corresponding MAC address. If the packet's destination IPv4 address is on the same network as the source IPv4 address, the device will search the ARP table for the destination IPv4 address. And the next is if the destination IPv4 address is on a different network than the source IPv4 address, the device will search the ARP table for the IPv4 address on the default gateway. Each entry or row of the ARP table links an ARP address, IPv4 address with a MAC address. We call the relationship between the two values a map. ARP messages are encapsulated directly within an Ethernet frame. There is no IPv4 header. The ARP request is encapsulated in an Ethernet frame using the following header information. The first point is destination MAC address. This is a broadcast address with this form requiring Ethernet NICs on the LAN to accept and process the ARP request. Source MAC address. This is the MAC address of the sender of the ARP request. The type is ARP message have a type field. This information the receiving NIC that the data portion of the frame needs to be passed to the ARP process. Because ARP requests are broadcast, they are flowed out all ports by the switch except the receiving port. Only the device with the target IPv4 address associated with the ARP request will respond with an ARP reply. After the ARP reply is receiving, the device will add the IPv4 address and the responding MAC address to its ARP table. When the destination IPv4 address is not on the same network as the source IPv4 address, the source device needs to send the frame to its default gateway. This is the interface of the local router. Whenever a source device has a packet with IPv4 address on another network, it will encapsulate the packet in a frame using the destination MAC address of the router. The IPv4 address of the default gateway is stored in the IPv4 configuration of the host. If the destination host is not on its same network, the source checks its ARP table for an entry with the IPv4 address on the default gateway. If there is not an entry, it uses the ARP process to determine a MAC address of the default gateway. For each device, an ARP cache timer removes ARP entries that have not been used for a specific period of time. The timer differs depending on the operating system of the device. Command may be used to manually remove some or all of the entries in the ARP table. On a Cisco router, the show IP ARP command is used to display the ARP table. On a Windows 10 PC, the ARP-A command is used to display the ARP table. As a broadcast frame, an ARP request is received and processed by every device on the local network. If a large number of devices were to be powered up and all start accessing network service at the same time, there could be some reduction in performance for a short period of time. In some cases, the use of ARP can lead to potential security risk. And a threat actor can use ARP spoofing to perform an ARP position attack. Poisoning attack. This is a technique used by threat actors to reply to an ARP request for an IPv4 address that belongs to another device, such as the default gateway. The threat actor sends an ARP reply with its own MAC address. The receive of the ARP reply will add the wrong MAC address to its ARP table and send these packets to the threat actor. And reflection question. Olcay and Ivan knows a lot about networking, including address resolution. Before this module, did you understand ARP and ARP tables? I had never thought about threat actor using ARP spoofing to perform an ARP position poisoning attack. Had you? Address resolution quiz. Which protocol is used to discover the destination address and need to be added to an Ethernet frame? ARP. What is one function of the ARP protocol? Obtain an IPv4 address automatically, mapping a domain, resolving an IPv4 address to a MAC address, maintain a table of domain names. No, is resolving an IPv4 address to a MAC address. Refer to the exhibit. PC1 on VLAN 10 wants to communicate with PC2 on VLAN 20. PC1 sends an ARP request to its default gateway. And GW1, how does GW1 respond? It's an ARP reply to PC2, no. PC1 on VLAN 10, okay, wants to communicate with PC2 on VLAN 20. Okay. It sends an ARP reply to PC2. It sent an ARP reply to PC2. It sent an ARP request to PC1. It forwarded the ARP request for PC1 to PC2. It sent ARP reply to PC1 with its own MAC address. What action does the ARP process take when a host needs to build a frame, but the ARP cache does not contain an address mapping? What action does the ARP process take when a host needs to build a frame, but the ARP cache does not contain an address mapping? The ARP process sends out an ARP request to the Ethernet broadcast address to discover the IPv4 address of the destination device. The ARP process sends out an ARP reply request to the IP for broadcast. No, no. Mm, yes. Which statement describe the treatments of ARP requests on the local link? They must be forwarded by all routers on the local network. They are received and processed by every device on the local network. Okay. And they are processing out an ARP request to Ethernet broadcast to discover the MAC address of the destination device. Okay. What is the aim of an ARP spoofing attack? The flood the network with ARP rapid broadcast. Okay. A cybersecurity analyst believes that an attack is. Mande. Sí, ahorita voy. A cybersecurity analyst believes that an attack is announcing a forget MAC address to network host in attempt to spoof the default gateway. Which command call the analyst use on the same network host to see that what MAC address the hosts are using to reach? Uh, and the next, what will a host do first when preparing a layer 2 PDU protocol data unit for transmission to a host on the same Ethernet network? It will send the PDU to the router. It will query. Okay. Which destination address is used in ARP request frame is this? Which protocol is used by a computer to find the MAC address of the default gateway on an Ethernet network? ARP. Question 11. Refer to the exhibit. PC1 attempts to connect to file server 1 and send an ARP request to obtain a destination MAC address. Which MAC address will PC1 receive in the ARP reply? The MAC address of switch 1, the MAC address of the port gigabyte 0/0. Okay. Excellent. You score 100%. Congratulations. You have passed the test. Well, review assessment reply quickly. Okay.